In the last few lessons, we've managed to create a Weather Manager object, which is able to perform the networking that fetches the live data from OpenWeatherMap, and then we're able to pass the weather into an actual Swift object, which we can access in a Swifty format, like this. In this lesson, I want to focus on getting hold of our weather conditions, because we need to be able to update this image view with a different image from the system SF icons so that it represents the condition of the weather. Now, if we take a look at the API docs for OpenWeather, you can see that they've got this section on list of condition codes. And this section here links to all of the condition codes that they use, and that refers to the ID property in the data that we get back. What do these IDs actually correspond to? Well, they're a way of encoding different weather conditions. So, for example, everything from 200 to 232 encodes some sort of thunderstorm, and there's apparently different types of thunderstorms, which I didn't really know about, like a ragged thunderstorm. Wouldn't want to be in one of those. Now, we know that we can get hold of the ID, which is the ID of the weather condition, and we can match it against these values to see what type of image we should show the user. So let's go ahead and do that. Instead of getting hold of the description, which we're not actually going to use, instead I'm going to change this property to ID, and the ID is an integer data type. And I can do this because the ID is actually nested inside at the same level as the description. So changing that over from the description to the ID, or you can, if you want to, just simply add it on as an additional property if you plan on using the description at some later stage. But they both live within this weather struct, which is an array of weather conditions that we're getting back, which comes from the entire weather data. So following it down, this is the first property, which goes into an array, which then has an object with a property called ID. So quite convoluted, but eventually we should be able to get a hold of this number. Let's go ahead and try to print that in our Weather Manager just to make sure that it's actually working. So let's see what it's like in Bali at the moment. And the weather condition code I'm getting back is 803. And if I check against this table, 800's 803 is broken clouds, 51 to 84%. Interesting. So in this case, I would probably just show a cloud in my app right here. So this is the perfect opportunity to utilize what you've learned about Swift switch statements a few modules back. So I'm going to set this to you as a challenge. Given that we have this ID, which I'll call let ID equal decoded data dot weather at the 0th index dot ID, I want you to create a function down here that we'll call get condition name, and it takes the input in the format of the weather ID, which is going to be an integer, and then inside this function we're going to return a string. And that string will depend on the weather ID. So we're going to call this get condition name and pass in the ID right here that we get back. And then inside this method, we're somehow going to use a switch statement to output a string. And that string should match the name of one of these symbols. So for example, if we were getting clouds, then maybe we would simply return the word cloud, which would match with this image's name. And if we got, say, rain, then maybe we would put cloud.rain to get this symbol. Because eventually what we're going to do is we're going to be using that condition name to change this image view here. So if we got cloud.rain as the condition name, that's what we would see. If we got just cloud, then we would get this image. If we got sun.max, then we would get this image. So feel free to pick and choose whichever icon takes your fancy, as long as they more or less match the condition name that we're getting back from Open Weather Maps table. And then when you get this condition name back, I want you to go ahead and print it so that when you run the app and you put in the name of a location, say in Paris, and you go ahead and get the weather for it, you should be able to get a name for a SF symbol that matches the weather condition of that location. Now, if you already know all about Swift switch statements and you don't want to complete this challenge, then you can also head over to the README file and you'll find the switch statement already written for you. But I recommend that more practice is always good. So using a switch statement, try and print out the name of an icon that matches the condition ID from Open Weather Map. I'm going to leave it up to you to pause the video and complete the challenge if you want to. All right, so here's our switch statement, and it looks at the weather ID that we get passed over and takes a look at its value and tries to match it against these cases. And these cases I've put in as ranges. So the range between 200 and 232 in the weather condition codes matches a thunderstorm. So out of all of these pictures of thunderstorms, I think the cloud.bolt looks quite nice. So I've decided to return cloud.bolt. And I've done basically the same thing to match all of these different conditions. And in the default condition where none of these cases match, then I'm just going to return cloud as the default option. Now, if you are at all confused about switch statements or the range operator, then be sure to head back to some of those Swift deep dives where we talked about those things in more detail. And that's the solution to the challenge. But now you might be noticing that this file is getting a little bit messy, and we're getting to the point where we kind of need to group some data in a custom data type. And that is, of course, the role of the data model. So let's do that now. Let's reorganize our code in accordance with the MVC design pattern. This means that we'll take some functionality out of the Weather Manager and put it into a separate file. That way, we'll have shorter and simpler files that are easier to understand. If I want to create a custom weather data model, which is able to figure out the condition name based on the condition ID, then I would need to go into my model folder and create a new file, which I'm going to call the WeatherModel. And I'm going to use this file to model what a weather object should look like. Let's create it as a struct, and it's going to be called WeatherModel. And it's going to have a number of properties. So we definitely need to have a condition ID property, which is an int. We also need to have a city name property, which is going to be a string. And finally, we also need a temperature property, which is going to be a double. So now I can go ahead and move this functionality of figuring out what the condition name should be based on the condition code or the weather ID. This is very much within the realm of the weather object. So let's go ahead and paste that in here. Now, back inside our Weather Manager, instead of having all these disparate pieces of information, I can create my ID as my decoded data weather ID. I can create my temperature or temp as the decoded data .main.temp. And finally, I'm going to create my city name, or I'm just going to call it name for short, from the decoded data.name property. So now that I've got all the properties that I want out of my weather data, I can create myself a weather object from my new weather model. So when we initialize it, we have to provide the condition ID, which is the ID, the city name, which is name, and the temperature, which is temp. Now, if I wanted to get hold of the condition name, then I can simply write weather dot get condition name, and I have to pass in the ID. But wouldn't it be nice if I could just have a property in my weather object that's called a condition name, and it manages to figure out what that should be, instead of getting my weather manager to call the method getConditionName in order to get the ID. This is a good opportunity to show you a cool thing that we can do in Swift, which is called a computed property. So we've got all three properties here, which are actually called stored properties, because all they do is they just store pieces of data. But I can also create a computed property. So I'm going to create it using a var keyword, and I'm going to call it the condition name. And it's going to have a data type of string, and then I'm going to open up a set of parentheses. And inside this set of parentheses, I'm expected to return or output what the value for the condition name should be. That would require me to work out the condition name, which luckily I've already got down here in the form of my switch statement. So let's paste that in here. And we can use the condition ID property value to switch and then check what condition it is to return this string, which is going to be equal to the condition name. So now I've got a computed property because this property, condition name, is going to work out its value based on the code inside these curly braces. What this allows me to do is, if I want to get hold of the weather condition, all I would have to do is say weather.condition name, and I can use it just like any other property. And if you run your app right now, you'll see it works perfectly just like before. But our code is now a lot better after the refactoring, and it's a lot more succinct and easier to understand. So what's the general format for computed properties in Swift? Let's go over the syntax for computed properties again. In order to create a computed property, it always has to be a var, because the value is always going to change. It's going to be based on the computation. And then we give it a name, so let's call it a property. And then we have to give it a data type. So let's say I want it to be an integer. Now, in between the curly braces, I have to provide an output that is going to be set as the value of this property. So let's say that I wanted to calculate, 2 plus 5. So this is the computation, and that means a property is going to be equal to the result of this computation, which is going to be 7. That's our computed property in Swift. And as practice and as a challenge, I want you to figure out how we can get hold of the temperature as a string with only one decimal place. So you've done this before using the string initializer, but I want you to turn that into a computed property now. And it should be called temperature string. And if you manage to successfully solve the challenge, then you should be able to print weather.temperature string. And when you run the app and check the weather, then you should get the temperature back in a string format with only a single number after the decimal place. So pause the video and see if you can complete this challenge. All right, so we've got our temperature string computed property here. And remember, we always have to provide a data type for the computed property. And then we open a set of curly braces and actually work out what it should be. So in this case, I'm going to return a string with the format of a single decimal place. So that was %.1f, and then I'm going to pass in my temperature, which is this double right here, as the property that's going to be formatted to this particular format. And now when you run your app, you should be able to see that whatever temperature you get back will be printed with only one decimal place. And this temperature string now has the data type of a string, ready for us to put into our temperature label. So in the next lesson, we're going to tie it all together and get our weather app working with all of these different components together. For all of that and more, I'll see you there.